Okay, all you tube junkies and reverb hounds out there in YouTube land, it's time for part 3 of our reverb tank extravaganza. In this one, I envision 3 separate parts. Number 1, let's dissect my 6G15 reverb tank to get an idea of the sort of structural design of it. Number 2, let's take a look with an oscilloscope at the signals, both wet and dry, that occur within the tank. And finally, number 3, let's plug in a guitar and see exactly what type of control each of these pots has upon the overall tone of the unit. If that sounds stimulating, then pull up a chair, grab a beer, and let's get started. Okay, in our dissection here, let's start off with the control panel. Now, I made this from scratch. I know you can get laser etched control panels and all other things. You can also buy kits for the 6G15, which offer you a chassis already made with a silk screened control panel. They offer cabinets if you want them. They also offer all the components, transformers, tubes, etc. for you to build a complete unit. And the beauty of it is it's like a buffet. You can pick and choose. Say, I want to make my own chassis and I want to supply my own tubes. You can buy a cabinet and you can buy all the internal components. So you can get what you want and not really have to spend more money than you wish to. But as usual, I decided I wanted to try to do absolutely everything myself. So to make this control panel, I started out with just a sheet of clear acrylic. It has some thickness, it's fairly rigid, and I drilled holes and fit it to the top of my chassis. Then I flipped it over and sprayed several coats of gold spray paint on the back, which gave it this nice gold color. Then I used rub-on letters on the outer surface to give me the identification of each of the controls and inputs. You can buy the rub-on letters at places like Hobby Lobby, all different sizes. You can get a lot more imaginative than I did as far as the types of font that you use and things like that. But I just wanted this thing to be very clear and obvious what each of the controls was. Now, this was only the second guitar electronics related device that I'd ever made, and it was quite a few years ago, and I have changed some of my tactics a little, and I will say that on this control panel the rub-on letters are rather fragile and really need to be protected. So you can either spray several coats of clear acrylic spray over the surface, or you can simply get another sheet of the same type of acrylic that's clear and machine it properly with all the holes and then lay it on top of this one so you actually have a sandwich with the rub-on letters in between. Now I'm going to undo these 2 screws and take the chassis out and lay it down so we can see what were the considerations that went into the wiring on this side and the placement of transformers on the back. Okay, I have the chassis out and you can see the shielded cables that go to the reverb tank. I didn't use jacks here to connect these cables. I hardwired one end of the cable into the circuit and then used a jack at the other end. That kind of cuts down on the connections and the problems associated with it. I also hand bent the chassis out of steel that is 35 thousandths of an inch thick. I'll have to look up and see what gauge that is. It bent fairly easily. I didn't really need a hammer on this one. And I silver soldered the ends in place. I didn't have a spot welder, so I just used silver solder. Now on the rear of the chassis, which cannot be seen of course with this in the cabinet, I placed the filter choke and the reverb driving transformer outside here. Notice that the axes are at 90-degree angles to each other, so they don't reinforce each other's electromagnetic field. My obsessive compulsiveness wanted me to center them perfectly. But the reverb tank is against the front wall and will be like in this position. So you have to be sure that you have clearance between the reverb tank and the transformers. So I had to position them a little further up toward the control panel to have proper clearance here with my tank, because I didn't want some rattling and thrashing going on due to the proximity of transformer and tank. To figure out the dimensions of the chassis, I looked at some of the plans that were available for the kits that are offered on the internet. And I found that the original 6G15 chassis was 15.5 inches long by 4.5 by 2 3/4. And that's exactly the size that I built my own chassis to. Once you have the chassis made, then you can proceed and actually build your cabinet around it because you want to have the walls of the cabinet very close to the sides of the chassis. Okay, and that's the way I put my controls. I believe it's the same as they are on the original 6G15, 3/4 amp fuse. I used a little green pilot light just to be different. Dwell, input, mixer, tone, and output. And then sort of oval holes here for those screws to come through from the cabinet so that you can move this front and back and it will come up real close in the rear to suit the back door of the cabinet. An important consideration is always to put grommets wherever electricity carrying wires pass through metal holes. Overall vibration and chafing and all that can lead to some hideous short circuit problems. So always use grommets. I used to get them at Radio Shack. I'll have to find some other source. There's grommets under here too. Now whenever I'm wiring up a circuit and I use point-to-point wiring, I always try to imagine worst case scenarios. And this is a rather large power switch. It just happened to be the one that I bought, and I didn't like how close the prongs were to the transformer, so I made a little cardboard insulating shield here to protect it. This is just simply a flat mounted, surface mounted power transformer, and I put in a couple of terminal strips here so that all of my components would be held at both ends solidly, so there could be no problem with them thrashing around and touching things they weren't supposed to touch. As you can see, the filter choke screw heads are visible right there. We've got the pilot light and the fuse holder there, and also here are the filter capacitors. I think on the original they might be on the back of the chassis and enclosed in a little doghouse, little metal structure. I didn't have room for that, so I just put them inside here. And to protect my sensitive reverberation circuit from the power supply, I put in this steel partition that cuts down on the amount of electromagnetic field that might be able to come over here and adversely affect my circuit. I didn't buy a full wave bridge rectifier. I just used diodes to create my own. I believe in the original they just used like 3 diodes in series. The full wave bridge is better. Just make sure that you get a transformer that doesn't have a center tap so that you can use the full wave bridge properly. Okay, as you can see, the pots are all mounted directly to the steel chassis. I don't use those copper grounding plates. I have no idea what they're thinking of. The steel works just fine. I did run a common ground, you see, to each of the bodies of the pots and then grounded it to the chassis. You can see that all the capacitors are out here with their values very obvious. The resistors. You know, you can still do point-to-point wiring and have it look nice if you square off your wire leads, make things parallel, and where it isn't just like a handful of linguini thrown into a chassis. I don't really use just star grounding where there's only one grounding point for everything. If you notice right here, this center lug of this terminal strip is grounded, and then I both bolted and soldered a kind of a master grounding lug right here for most of my wires, including my shielding and other things that I wanted to be absolutely secure in the grounding. Over here, there is another grounded lug here on this terminal strip. You see how so many components go to it. In the power supply, you see right up here that I soldered and bolted in a master ground for all of my filter caps, chassis ground, and things like that. The floor of the chassis is wired in much the same way. You'll see that all the AC filament leads are tightly twisted, as all AC leads should be. I did not follow the rule that I gave you recently, and that is to bring your filament leads in from above and swoop down to the tube socket. In this case, they are located kind of around the perimeter, which is not supposed to be the best idea, but it does work in this case, thank heavens. Here at the bottom of the chassis, I use a 6V6. What we can do when we start running a guitar through this is I'll do a 6V6 and a 6K6, and you can decide what you like best. In my case, it was the 6V6. And then we have our 12AT7 and our 12AX7. This is for your foot switch control, so you can turn on the reverb remotely. And here are the grommeted, shielded outputs and input from my reverb tank. My outside dimensions are 19 inches by 10.5 inches by 7.25 inches. Those are the outside dimensions. Okay, we saw in part 2 that mounting the tank along a vertical wall from left to right was the best possible arrangement, and that's the way the tank is mounted in this and in the Fender 6G15 cabinet. Okay, now when you do that, if you use the dimensions I did for my cabinet, you'll have just enough room on either side here so you get a little airspace at the sides of your tank. And because the mounting screws were here and I didn't want to try to go through that front panel, I put in some vertical struts here and here so that my screws would have something to go in to hold the tank in position. Now you'll notice by using the struts, it gives me a pretty good space back here, probably 3/4 of an inch, between my front panel and the bottom of the tank. And that's very, very important for a reason that I will show you in just a second. Now, reverb tanks are rather fragile, and many, many times I've seen a faulty reverb as a result of damage to the tank, and the tank is generally damaged during transport. People thrash it around and the little tray in here with the springs bounce around and stress the transducer wires, the little tiny little wires that are holding those rod-like magnets, the springs themselves. It's just subject to all sorts of physical harm. And I think you'll agree it makes good sense if during transport you could have a nice gentle piece of foam come into the tank here and push firmly against the springs and tray to sort of press them and contain them against the rear wall of the tank. Notice that it's up high here floating on the springs. I want to push it down like this so that springs and tray are held immobile and absolutely cannot move around when I move the tank. I think you'll also agree it makes no sense to have to remove the tank and take away the foam every time you want to use the unit. So there has to be some sort of mechanical way of pushing this against the tray and springs and then releasing it when you want to play the unit. Now, I saw pictures. I've never owned or worked on a real Fender 6G15. So I had to analyze photographs that I saw on the internet, and I saw that there was a kind of a steel bar that came out from on the floor of the cabinet and seemed to go up inside behind the tank. And it was my assumption that it's probably pushing a piece of foam to do exactly what we think needs to be done. So I came up with this device, which is quite similar to the one that Fender uses, but different in a couple respects. See the vertical arm that goes up here? That's holding the block of foam right back here inside the tank. Then the arm comes down, and you see there's 2 screws in the floor of the cabinet, and there's a milled slot so that the unit can slide back and forth and be controlled so that it can only move perpendicular to the tank. Now, that's fine and dandy, but how do you release it? On the Fender one, I believe they have a little L notch here, and or probably up here, and you pull it and then twist the arm so that the screw would go into that notch and lock it. I don't like the idea of pulling back and twisting. To me, that's adding stress. So I wanted mine to only move straight forward and back. So I came up with an idea of a sear-like lock, that it would be like locking the hammer in a pistol. And so I made this sear. Now watch. When you pull the sear out of the way, the whole unit jumps forward and uncages the springs and the tray. There's no wiggling around here and trying to force it forward. I have a spring here that moves it forward, and I have a spring over here that activates the sear. Now the beauty of this is the concert's over, the groupies are waiting, and it's time to cage your tank. Watch this. You just pull back, it locks, it's done. You can move your 6G15 now without any concern for your reverb tank. I'm kind of proud of this, so I'll demonstrate it once more. Pull the trigger, tank is released. Concert's over, pull it, sear locks in, we're done. One thing I'll caution you about is when the aluminum arm pulls the foam away from your springs and platform to allow the reverb unit to work, be sure it can move far enough away that the foam is completely clear from the springs. You don't want the foam touching the springs in any way and dampening their reverb action. Now, about the only other part that may be of interest is that front panel, and it's simply cut to fit into the recess here of the cabinet. It's a solid piece of wood. You don't have to cut a hole and make a speaker baffle or anything like that. It's just solid. And I used, I'm going to say probably 3/8 inch fiberboard of some sort, and then covered with a nice upholstery style material. You don't have to worry about it decreasing your treble or being transparent as far as sound waves or anything, because no sound waves are coming through it. So you can pick out something really snazzy looking and screw it in. And I thought the gold here with the gold screws, the gold fittings, gold control panel and all, just loaned kind of a nice touch to the unit. And the cabinet uses finger joints in all 4 corners, just like every cabinet that I've shown you in any of the videos that I've posted. The covering method is exactly like the one I showed in the how to cover the cabinet video, using the overlap joints. Now, a lot of people moan and groan that how hideous this is. Well, tell it to Fender, because that's exactly the way they did it. Okay, and in this case, I thought, well, why not? If you're imitating a Fender 6G15, go all the way. So this is how the original was done. If you don't like it, just slice with a razor blade, pull out the lower piece, and make your joints butt up evenly. Okay, that said, let's button this jewel up and see what the signals look like wet and dry using an oscilloscope. Rumor has it Jack is hiding somewhere in the bedroom, but we have no idea where. Oops, there he is. Okay, now I'm out in the workshop, and I have my signal generator putting out a 10 times 100 pulse, so it's a 1,000 cycle per second signal. And we're putting it into the 6G15 as if it were a guitar. And I have my oscilloscope leads connected in here to 2 locations that I will show you on the schematic. Then we'll take a look at what the oscilloscope trace looks like. For this first oscilloscope view, I've connected one probe down here to the grid of the dry 12AX7 triode, and the other probe right up here to the grid of the wet 12AX7 triode. So we're going to see the signal that comes in dry straight from the signal generator, and we're also going to be able to compare it to the reverb signal as it is applied to the final 12AX7. First, we'll see the dry signal, and as you can see, it is a very uniform 1000 cycle per second input sine wave. Next, we'll look at the wet signal. Now, I've got the dwell at 0. Let's crank it up and watch our reverb take place. As you can see, it's very similar to the dry signal, except the fuzziness here reflects the effects of the reverb tank on the delay and echo, so that our signal, instead of being a discrete sine wave, broadens out to give us that twangy reverb sound. Now I'll flip the switch and show you both curves at the same time. Now look at that. You can see the dry signal and the wet signal at the same time. And also, a point that I'd like to make is, look at how well the phase agrees. Now that's been a subject of some argument in the comment section, but as you can see, they are definitely in phase. For our second oscilloscope view, let's take a look right here on either side of the mixer control. Let's see what the wet signal looks like at this point after passing through the wet 12AX7 triode, and let's see what the dry signal looks like after going through the cathode follower that precedes it. Here is the dry signal after passing through that lower triode of the 12AX7. As you recall, it's connected in a way that the signal output is from the cathode, and it is a cathode follower, for those of you who are familiar with the term. And cathode followers are known to not increase gain. And as you can see, the height of the curve, which indicates the amplitude or the strength of the signal, is exactly the same as it was before the cathode follower. Okay, here's our wet signal. I think you can see just how much the amplitude has been increased by that final stage of amplification in the 12AX7 wet triode. Now let's crank in a little dwell and see just how fuzzy it gets. Wow, look at that. I think you can see that not only was the amplitude increased, but the overall reverb effect is significantly more evident here. Much more evidence of the echoes, bounces, delays, and everything else that's taking place in the reverb tank. Let's superimpose the dry signal on it and bring it down to size, and I think you'll see that the two tracings are still beautifully in phase. Now for our final oscilloscope view, let's use our probe to connect between the output and ground so that we can see what type of signal comes out as we run the mixer from minimum to maximum and back. Okay, we have the dwell set at about 2.5 out of 10, the way it's been for all our previous oscilloscope images. Let's start to crank in, using our mixer, a little wet signal. We see that the amplitude starts to diminish, so let's crank the vertical deflection up and continue. Almost looks like Popeye's arms or something. But look at that. It's rather asymmetrical, rather unusual, but that is the reverb signal. It has broadened our sine wave of our 1000 cycle per second signal. Let's now crank the mixer out back to all dry, reduce our vertical deflection, and we're back to our dry signal. I get asked all the time about oscilloscopes, and this is my own personal one. I got it from David over at El Paso Tube Amps, and it's all you need really for doing what we do. It's a little 2205 GM. It's a 40 megahertz oscilloscope. They're fairly inexpensive, but you'll find that the probes, when you start buying probes for them and other accessories, that can run the price up just a bit. Jack, where are you? God, he is so good at hiding. Now it's time for the part you've probably been waiting for, which is the sound testing of the 6G15 clone. I've got it connected to an old 1973 Silverface Vibrochamp, and I think it's a great combination because between the reverb of the tank and the really nice tremolo in the Vibrochamp, we've really got almost like a homemade Princeton reverb or even deluxe reverb here. Okay, step one, we got them both turned on and warmed up. Now let's just get a baseline here with the dwell set to 0 so that we can hear what the dry signal sounds like coming through that bottom route through the signal of the 6G15 into the amplifier. This will be the sound that we hear with absolutely no reverb added. Now in this setting, the mixer and tone control on the 6G15 have absolutely no effect. It's completely bypassed. Now, just so we can be sure that the tank does not affect the guitar signal as it passes through the dry signal path on its way to the amp, let's plug the guitar directly into the amp and see how it sounds compared to when we plug into the tank. Now all of these first tests are going to be done with the 6V6 in place. Later we'll switch to a 6K6 for comparisons. Okay, now I'm going to crank the dwell up to like 2.5 out of 10. The mixer and the tone are both straight up at 12 o'clock. The amplifier is exactly as it was set for the dry run. Pretty good reverb already. Now let's move the dwell up to 12 o'clock to give us like a 5 out of 10 reverb effect. Okay, all the controls then on the tank are at 12 o'clock. I think you see what dwell means. Look at the duration of the echo effect. It's several seconds. Now let's see what it sounds like with a dwell at 3/4. This would be like 7.5 out of 10. Wow. A big increase in dwell noticeable. That's about all the reverb a normal human can stand, but let's crank it to 10 just to see. Okay, the dwell then is at 10, and the mixer and tone are both straight up at 12 o'clock, kind of a neutral position. That's like about 6 seconds of dwell, even greater than I was led to expect. Now let's see how the mixer affects the tone. I've got the dwell at 12 o'clock, the neutral position, which gave us a whole bunch of reverb effect. Let's turn the mixer down to 0. Now let's try the dwell at 50% and the mixer at only 25%. Now let's crank the mixer up to 50-50. Here goes. Okay, we've already heard that. We've had both of those settings at a 5 out of 10. Now let's crank the mix all the way up to 100% reverb. Okay, here goes. The dwell is still at 5 out of 10. Wow, you kind of miss the dry signal to clarify things and sort of give you that emphatic first signal, and then with all the echoes after. With the mixer at 100% wet, you're almost just getting all echoes. Okay, now I've got the dwell and mix at 5 out of 10, kind of a neutral position, 50-50 on the mix. Let's see what the tone control does. I'm at all the way counterclockwise at a 0 tone control setting. Notice how the reverb effect is diminished because the tone control is only allowing low frequencies through. Higher frequencies work better in a reverb tank. So let's crank the tone up to 12 o'clock, which would be 5 out of 10. There, with the introduction of a lot more high frequency, you notice that our reverb effect is back. Now let's crank the tone control all the way to full treble. Wow, about as bright as it gets. I guess for some that would be ideal reverb. For me, I kind of like the middle setting on the tone a little better, where you get not so much harshness. Now for all you tremolo hounds out there, we've got the tank set, all 3 controls at 5 out of 10, but we've got a 5 intensity on our tremolo on the Vibro Champ. Pretty sweet. Now let's try a 10 intensity on the tremolo. Pretty swampy. Now there seems to be some argument about which is the better tube to use in the reverb tank. 6V6 was used in the reissue tank, 6K6 was used in the original. Let's do a side-by-side comparison here of both tubes. First will be the 6V6. All of the reverb tank controls are straight up at 12 o'clock. Now the 6K6 with all the same settings. Do you notice much difference? The 6V6 at 3/4 dwell. I personally think the 6V6 drives the tank a lot harder. Okay, now we'll try the 6K6 at 3/4 dwell. Now the 6v6 at a dwell setting of 10. And now the 6k6 at a dwell setting of 10. What I think it boils down to is if you want to use a 6v6, you can almost overdrive the tank, but you don't have to. You can set your controls where you get exactly the reverb you want. With a 6k6, I don't think you can overdrive the tank, so you have to use higher dwell and mixer settings to get about the same tone as you do with a 6v6. Okay, let's play a couple tunes here with the tank settings all at 12 o'clock or 50% each. We'll play one tune with a 6v6 and then one tune with the 6k6 to give you a better comparison of how the two tubes perform. Well, on that happy note, I think it's time to conclude this massive video, the longest one I've ever made by far. I think in conclusion we can say that the dwell, mix, and tone controls on the 6G15 reverb tank allow for just about every possible level of reverb, regardless of whether you use a 6V6 or a 6K6 tube to drive the tank. Granted, the tank is capable of reverb that is way over the top, much more than any normal human would want. But just like guns and horsepower, it's always better to have it and not use it than the other way around. I also wanted to extend our heartfelt thanks to all our Patreon and PayPal contributors. With your help, we'll continue to offer advertisement-free videos for as long as we're able. And I'm hoping that more of you out there will see fit to subscribe to our channel and to either pledge or contribute. The links are in the video description. Since we've run so long, let's still go to the car show, but I think we're only going to have time for just a few cars. So I'll see you there. Here's a front runner in the what the hell category. Looks like a Nomad 55 Chevy with, oh my God, a big block Chevy engine with a high rise. 396, 427. Good grief. Who would expect that, huh? What fun this must be at the stoplight when the snot nose and the Mustang GT pulls up next to you and starts giving you the evil eye. Very tasteful. I think that would qualify as a ratish looking rod if ever there was one. Wow. Here's today's leading contestant in the Holy Shit Awards. Notice the 427 on the fender.
No pictures, no pictures.
It appears to be an LS7 427 with some ungodly looking induction system. I shudder to think what happens when you step on the gas in this. Wow. Not only that, but it's a damn nice looking car too. Look at that, just straight as an arrow. 6-speed manual. Good Lord. Not too shabby. As I've got a 57 Chevy idling here. It's a blown small block engine, probably 350. Red your color, that's your car. Beautiful, straight as an arrow. And now for the what in God's name are you doing here category. The 4-door station wagon in cosmetically hideous condition. Will rally wheels. And it says 350, which is probably optimistic. I don't know, not really to my taste. And now a real sleeper. It's an old Valiant. Fairly straight, but very, very visually unexciting. But check this out. For you Mopar fans, I'm thinking the bulk of the money spent on this car was spent right there. Pretty slick. Well, here's a nice historical perspective. We go from a 1910 Ford Speedster to a Cobra, probably a replica, 427 Cobra. There you go, Ford's history in 5 seconds. Here's a nice looking T-bucket. I like the wheels. Body has the right stance. And nice basic engine. Overall a nice car. I'll tell you though, once you've ridden in one, you probably wouldn't want to ride again, depending on how sober